AOPS, Volume 1, The Basics, number 99. A base 2 numeral consists of 15 digits, all of which are ones. When tripled and written in base 2, how many digits does this number contain? So when you're dealing with questions with many digits, it is often bad to just write them all down because not only can you make an error and not write one of the digits down, but it's very easy to get to mistakes by writing down 15 ones. And that gets very confusing and blurry the more and more you work on it. So I'm going to simplify things. I'm going to say that this number of 15 ones will be represented by the variable of x. So, okay, so with this variable of x, it says that we triple this number, so 3x, and write this in base 2. But x in itself is already in base 2 because it tells us that the 15 digits of 1 is already in base 2. So we don't have to worry about converting this into base 2. And here comes the ingenuity behind this problem. 3x, well, what can I rewrite 3x to be? The sum of what two numbers, if you will. That would be 2x plus x, correct? Well, 2x plus x, what is the number 2x and what is the number x? We previously assumed x to be equal to the 15 ones, the number that we're given with. So we know what x is, but what is 2x? Well, 2x is nothing more but the 15 ones added to a 0 next to it. So it'll be x 0 plus x. And what do I mean by x0 and how did I even get x0? Well, first of all, uh, this is a little trick that you must understand with dealing with different bases. So let's say I have the number 2 times 1001, which is in base 2. And since 2 is greater than 1, therefore we must carry and do some operations. So 1001 times 2. 1 times 2 is 2, but 2 is greater than 1. Hence, we must put down a 0 and carry the 1. 1 times 0 is 0, so we put down, or 0 times 2 is 0, plus 1 is 1, so we put down here. And since this number is 1, we don't have to carry anything over. 0 times 2 is 0, plus nothing will be 0. 1 times 2 is 2, but 2 is greater than 1. So we put down a 0 and carry a 1 over to get 10010. So you see here that when we multiply any number in base 2 by 2, we just get the number with a 0 next to it. And this makes perfect sense. Why? What is base in base 10? 23 times 10. 23 times 10 is just 230. We just added a 0 next to it. And the reason why we can do this is because this is in base 10. And since 10 is greater than 9, 9 being the highest number that a base 10 numeral can have, we must carry the 1 over when multiplying 23 with 10, hence obtaining 230. This is the same logic for any other base, such as in base 5. If I have 23 times 5, 3 times 5 is 15. 15 with the units digit of 5, well, 15 in itself is already greater than 5, so we must carry the 1 over and put down a 0. And therefore, this will be equal to 230. This is a tip, advice, that will work for all bases of all numbers. And the proof behind this is very elegant and simple. But we'll get to that another time. For now, you'll just have to accept that 2 times any number in base 2 will be equal to that number added to a 0 next to it, hence having 0 here. And x will still be the 11, or not 11, the 15 ones. So from here, this is 16 digits, and this is 15 digits. And the summation of this will be equal to a number that contains 17 digits, which is the solution to our question. And while you might not get it and you might find it very arbitrary for me to say that without some proof and reasoning behind it, we can reason this out through wording, or we can just do the algebra. And for those who are already familiar with the sum of two binary numbers, you can click away from this video now. But the logic behind it, if we're not going to do the algebra, is this. Since we know that in binary, so in binary numbers, there can only be zeros and ones. So if we have 15 ones added to a 0 with 15 ones summed together, if this is 1, 1 plus 1 will be 2, so you have to put a 0 and carry the 1. And this continues for all 15 digits until we get to the 16th digit of 1, adding 0 because 1 plus 1 is 2 is greater than 1, so we must put down a 0, carry the 1, and put down an extra 1, having 2 digits extra than the 15 digits that we had summing the 15 digits together previously, containing 17 digits. But if you do not follow me still, that is completely fine. I will be explaining this visually by doing the algebra itself. But for those of you who already understand it, the answer is 17 digits. All right. So for those who don't understand it, This is the solution and the reason behind it with the algebra. So we have the number with 15 ones and 1 0. And I'm going to be doing this very precisely because it is very important for you to get a good understanding when you first deal with these type of questions. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 with a 0 added to the 15 ones. So 15 ones will be lined up like this, summed together. So in binary, as a quick review, can only contain 0 and 1. And if a number is greater than 2, then we must carry a 1 over to the next place value. So 0 plus 1 is 1. 1 is equal to 1 and less than 2. So we don't have to carry anything over. We can just carry a 0 over. 1 plus 1 is 2 plus 0 is 2. But 2 is greater than 1, the greatest number that a binary number can have. So we must put down a 0 and carry the 1 over. 1 plus 1 is 2 plus 1 is 3. 3 is greater than 2. Hence, we must put down a 0 and carry another 1 over. 1 plus 1 is 2 plus 1 is 3, which is also greater than 2, and therefore we must put down a 0 and carry the 1. And you see here that this pattern continues. This will be 0, carry the 1, this will be 0, carry the 1, and this goes on for each of the 15 terms, which is these 15 numbers. So these are the first 15 digits summed together. So we get 0, 0, 0, 0, 0, 0, 0, 0, 0. And from here, we carry the 1. 1 plus 1 is 3, greater than 2. Put down the 0, carry the 1. So all these zeros with this 1 will already contain 15 digits. Okay, you can count them out if you want. But then we carry the 1 over to this 16th one. And 1 plus 1 is 2, but 2 is greater than 1. So we must put down a 0 and carry a 1 over again because we have an extra 1 in this binary number. Hence, 1 plus 0 will give us 1. And remaining with the 1 0 will give an extra of 2 digits. Hence, 2 digits added to 15 digits will give us 17 digits, which is the solution to this question. And the summed number of these two terms. And you see here how easy it is once you understand the concept behind it. So that is the reasoning behind this question and the thought process that you need to have when you're summing any two numbers in different bases. Nonetheless, the solution to this question is 17 digits.